What we're going to do now is find an angle measure using the law of sines. Now to do this, we'd need a couple different pieces of information. So let's say we need to know at least one angle. So let's say we knew that this angle was 25 degrees. Then we need to know at least the side length opposite it, because law of sines works angles and opposite sides. So let's say we knew that was 12. And then we need to know one other side. So let's just say, for argument's sake, that this side is 7, because it appears that it's shorter than the 12. Now, first off, is this an ambiguous case? That is, are there two possible triangles? The answer would be no, because if we look at the angle and the side adjacent to it, and we compare that side that's adjacent to the side opposite the angle, the side opposite is much, much longer than that, so we don't have to worry about the ambiguous case. So then we can start using the law of sines. What I like to do is pair these things off. We know that the 25 and the 12 are going to go together. And then we know that the 7 and its opposite angle, which would be this angle over here, would be going together. So we do need to then label that. Let's go ahead and call that angle B, just to be unoriginal. So that means then we could set it up as the sine of angle B, which we're trying to find, and I like to put the unknowns on top, over its opposite side, which is 7, would equal, now remember, you can only take the sine of an angle measure. So sine is to a sine of an angle to a side length is to the sine of an angle to the side length. This gives us an equation which we can then, with a little bit of manipulation, solve. So we go ahead and multiply both sides by 7. So that becomes 7 times the sine of 25 degrees divided by 12. And in order to ensure some more accuracy, when I take the inverse to get b by itself, that is, I take the sine inverse. Now I want to make sure I'm in degree mode, of course, in my calculator, if I want my answer in degrees, which I must because I started in degrees. I'm going to try to put this into the calculator all at once. That will reduce any intermediate rounding and ensure that my answer is going to be more accurate. So when I do that, and this is where a little bit of practice can come in handy, and I take the sine inverse of 7 sine 25 and then divide that result by 12, I get 14.27, or to the nearest whole degree, which is the level of accuracy we want to go with, that is 14 degrees. That means that this angle is 14, right, like that, and that's it. We could then find the other angle by subtracting from 180, 180 minus 25 minus 14, and use the law of sines to find the side length.